This is the 40th session on relative velocity. In this video also I will take up one more problem in two-dimensional relative velocity collision problems in which relative acceleration between two moving points is non-zero. Okay. So to take up this problem, I write down the problem here. Fine. P1 and P2 are two moving points whose initial coordinates are 0, L and 0, 0 respectively. L and 0, 0 respectively. Point P1, point P2, point P2 moves along the straight line y equal to minus x with constant speed v. With constant speed v along increasing x values. Along increasing x values and moves to v with respect to ground so that its velocity is always aimed at P2. Find after what time the 2 points meet. Find after what time the 2 points meet. Okay, fine. I'll grab it, okay, fine. So draw the diagram, fine. So I draw the diagram. This is x-axis, this is y-axis. This is the origin of the coordinate system. Initially P2 was at origin, P1 was somewhere here, 0, L. So this distance was just equal to L. This is a straight line y equal to minus x. It makes an angle of 45 degree with the positive x-axis, 45 degree by geometry, coordinate geometry. P1 is here, L distance. Now P2 begins to move something like this, and P1 moves at a constant speed 2v, such that its velocity is always aimed towards P2. So the diagram will be something like this. At certain instant t, P2 will come here and P will move something like this, like this. If you extend it here, so at time t, this is P2, P1 at time t. This is P2 at time t. P2 is moving at a constant speed v. P1 is moving at a constant speed 2v. 2v is directed towards P2. This angle you extend it, assume this angle to be theta. This angle is 45 degree because equation of line is y equal to minus x. Let the separation between P1 and P2 at time t be equal to r say. So dr by dt, rate of change of r with respect to time, that is equal to rate of increase of r minus rate of decrease of r. Now see, velocity of P2 is here v. Its comparator on this line is v cos theta. V cos theta tends to increase this r. So rate of increase, and this 2v causes r to decrease. So rate of increase of r will be equal to v cos theta minus rate of decrease of r, that is just equal to 2v. Alright. So we shift dt to that side. V cos theta dt minus 2v dt. Now evaluate this integral. Suppose capital T is the time after which the 2 points meet. 0 to capital T. Achha, R is the separation between the 2 points at time small t. At time 0, R was just equal to L. Lower limit of R is L. Upper limit of R becomes 0 when they meet at time capital T. So this will be minus L equal to, V will come outside the integral, but cos theta remains because theta is changing with time, minus 2vt. So minus L equal to, let's call this integral as I1 for the sake of convenience. So minus L equal to Vi1 minus 2vt. Okay, fine. Minus L equal to how much? Vi1 minus 2vt. This is equal to minus L. Now what we have to do? See, when at t block capital T, the 2 points meet, they will meet on this line. So what will be the situation at t block capital T? So one more thing, see, at t time, coordinates of P1 are x comma y. I draw a line through P1 and parallel to x-axis, this one. Now here also I draw a line passing through this point and parallel to x-axis, this one. This is pi by 4, this is also pi by 4, corresponding angles. This is theta. This total angle is how much? 45 degree plus theta is the total angle. This angle also by corresponding angle, this angle is also be equal to theta plus 45 degree. This is theta, this is 45 degree. The total angle is theta plus 45 degree. This angle is also theta plus 45 degree. X component of velocity of P1 is 2v cos theta plus 45 degree. That is equal to dx by dt. So dx by dt is equal to 2v cos theta plus pi by 4. 45 degree radians, now it becomes pi by 4. So dx becomes 2v cos theta plus pi by 4 into dt. Now integrate this integral both sides. T, a limit of t will be 0 to capital T. Initially x coordinate of shape S1 was 0, it was on y axis. Now final x coordinate of shape S2, point P1, sorry. Final x coordinate of point P1, that we have to find. So at this I'll write down, okay. X1, let's call it say xf. Now how to find xf? See, xf is the x coordinate of point P1 when 2 points meet. 2 points will meet on this line of motion of P2, okay, because it is moving along that line. See, when the points meet, the situation is something like this. The points meet at t block capital T, okay. This is equal to x-axis. This is y-axis. This is a line. y equal to minus x. At t, capital T, P1 and P2 both come here. 0 to capital T time has passed by. P1 moves at a constant speed v along this line. This distance just becomes Vt. This angle is also 45 degree. The x coordinate of P1 and P2 both are equal because they have come to the same point, they have collided. The x coordinate of P1 and P2 both become Vt by root 2. And y coordinate becomes minus Vt by root 2. Because y axis, positive axis is this side, this is moving in that direction. So this is the xf. Find x coordinate of both the points, P1 and P2, also of P1 also. Alright. I'll rub this here, okay? So I'll rub this, okay? This also I rub, okay? So now I find xf, I write this Vt by root 2 here. So Vt by root 2 is equal to 2V. This I break from trigonometry, cos theta plus cos A cos B minus sin A sin B. Cos theta plus pi, cos theta cos pi by 4. Cos pi by 4 is 1 by root 2. Minus sin theta sin pi by 4. Sin pi by 4 is also 1 by root 2 into dt. 1 by root 2 comes outside the integral. 2 by root 2 becomes root 2. And this integral, okay. V root 2 bracket cos theta dt minus sin theta dt 0 to capital T. So V root 2 is just equal to, this integral is I1. And let's call this integral as I2. That is equal to Vt by root 2. Okay, fine. Alright. Now V will go away. Root 2 becomes 2. So this, from this we get I1 minus I2 is how much? T by 2. I1 minus I2 becomes how much, tell me? T by 2. This I1 minus I2. So I1 minus I2 becomes how much, tell me? T by 2. Fine. Now what we have to do? Now one more thing, we have to equate the y coordinates also. When the two points come here, the y coordinates also become same, minus Vt by root 2. Fine. I love this one, okay? Fine. So now see, the point P1 is here at time t, its velocity is 2v. It makes an angle of how much with positive y axis? 90 plus this angle. This angle is pi by 4 plus theta, this is pi by 2. So y component of velocity of P1 at time t is vy. That is just dy by dt. That is equal to 2v cos of angle between 2v and positive y axis. This one, pi by 2 plus pi by 4 plus theta. Pi by 2 plus pi by 4 plus theta is 3 pi by 4 plus theta. 3 pi by 4 plus theta. Okay. So now I'll break this also. Cos A plus B, cos A cos B minus sin A sin B. Cos theta cos 3 pi by 4. Cos 3 pi by 4 is minus 1 by root 2. Minus sin theta sin 3 pi by 4. Sin 3 pi by 4 is simply 1 by root 2. This is equal to dy by dt. Okay, fine. Now I rub this here, okay, fine. I rub this, okay. So I again need to transfer that side, okay. So dy is equal to minus 2v by root 2 minus 2v by root 2 cos theta dt minus, this also becomes minus 2v by root 2 sin theta dt. Now integrate this on both sides. Again, limit of t is 0 to capital T. Initial y coordinate of this point, moving point, this was how much? P1 na. This y coordinate was initially L, and finally its y coordinate becomes how much? Minus Vt by root 2. So minus Vt by root 2, minus Vt by root 2 minus L, minus V root 2 integral cos theta dt I1, minus V root 2 integral sin theta dt, that is just equal to I2. Okay, fine. So all this minus goes away. I divide by V root 2. So I get what? I1 plus I2 is equal to, if you divide by V root 2, how much will it be? T by 2 plus L by what? V root 2. So these are the three equations. First equation, this one. Second equation is this one. And third equation is this one. Okay, fine. The first equation is this, minus L equal to this. Second equation is this. And third equation is this. Now we have to find capital T from it, okay? So we have to remove I1 and I2. Alright? Fill up this one, alright, fine. See, if you are preparing for JEE Advanced especially, you have to solve these kinds of problems. Just solving simple problems is not sufficient, because you have to solve all these type of problems you solve, then only you are going to get speed and confidence and accuracy, okay? There is no limit. JEE Advanced is simply open-ended. As many problems as you solve, it's going to be beneficial. One cannot say that if we have prepared this much, then JEE Advanced is done. No. But JEE Mains you can be, because JEE Mains they don't select go beyond a particular level. But in JEE Advanced it's nothing. It's open-ended. You know, so as many problems as you solve, it's going to be advantageous to you. Fine. So now we will net from this. So I get this equation. Okay, fine. So I add what I have to net I2. I add second and third equation. I add. If I add second and third equation, I2 goes away. You can see. I1 plus I1 becomes 2I1. 2I1 becomes how much? T by 2 plus T by 2. T. L by V root 2. Now I1 I remove from this I1. This I1 I put here. Okay. So minus L equal to V I1. T by 2 plus L by 2 V root 2. Minus what? 2 Vt. Alright. So this becomes minus L equal to Vt by 2. Minus L by 2 root 2. Minus what? 2 Vt. So 2 Vt and 3 Vt by 2. L. This becomes how much? Just let me check the calculation once again, okay? Just let me check it up, huh? Okay. I1 plus I2, 2I1. 2I1 becomes how much? T by 2 plus T by 2, T plus L by V root 2. L by V root 2, fine. Minus L equal to V times this minus 2 Vt, fine. Okay. Alright. So I get 3 Vt by 2 equal to, I think something mistake is going on. Some mistake somewhere. Some mistake somewhere has been done. Just let me check it out, okay? Just give me half a minute, huh? Minus I2 cos theta minus sin theta. Minus I2 equal to T by 2. 2I1 becomes T plus L by V root 2. Minus L equal to V times I1 becomes T by 2 plus L by V root 2. 2 V root 2, okay. Minus 2 Vt, fine. Okay, fine. It's alright. This is just equal to Vt by 2 is plus, okay. Alright, fine. Alright, just a careless mistake, okay, fine. It's right to rectify it, huh? So it becomes 3 Vt by 2 equal to L plus L by 2 root 2. So T becomes 12 by 3V, 1 plus 1 by 2 root 2 is the required answer. Fine. So this is the required time. Okay, after this much time, the 2 points will meet each other. 12 by 3V, 1 plus 1 by 2 root 2 is the required answer. Alright. So this problem I discussed in this 40th session. Okay. In one more session, I'll take one more problem on this two-dimensional relative velocity collision problem in which A relative is non-zero. So again, one thing should be noted again in this problem, we cannot say this. As I specified in the mentioned in the previous video, this is not valid. Is not equal to u relative y by u relative x. This we cannot say, because that is true when relative acceleration is 0, but here relative acceleration is non-zero. So this cannot be stated. This is a false. Okay. So this is the required answer. All right. So I close this also. All right.